the that idea mixed with different concepts. That is what the priority for advance. Okay, read the question. It's something RC circuit is filling up or removing this is filling up the capacitance. Half of the volume is filled by the this particular dielectric slab. Then is asking what will be the heat generated in this circuit. Okay, let's take this. So initially, this is a circuit. Resistor R. Volt EMF, this R. So initially, what is the charge on this? Q naught minus Q naught. So what is the Q naught? Q naught should be equal to C into E. So this will be 2 into 3, 6 coulombs. Okay, leave it here. Now I'm going to place a slab. I say what will be that? Let's go in order. Will be in safer position. I'm going to bring a slab. And look at the condition what he has put. Half the thickness of the capacitor filled with a dielectric slab of dielectric constant K equal to 2. Now get into the of the this one. So calculate now the effective capacitance. So earlier capacitance was capacitance, say like it's C naught. Let me write C naught. It'll be easy for you because so many. So now what is the new capacitance? New capacitance will be C. How to calculate this? So it is half filled. If you know directly the formula, well and good. You can easily get into, you can save time. There's the advantage here. C equal to F naught A D minus T 1 minus 1 by K. Am I right? Epsilon naught A D minus T into 1 minus 1 by K. What is the dielectric constant? 1 by 2. So F naught A 4 F naught A by 3D. F naught A by D was capacitance. No, what is C naught? What will happen to the capacitance as got increased? No, it's got increased. So what do you expect the charge?
Increase.
Okay, now okay, of the thickness are filled with a dielectric of constant as shown here, the system is again allowed to attain steady state. Okay, let's not bother. Finally, what will happen? Final steady state charge will be Q naught minus Q naught will take it. So again, finally, when it reaches steady state, so what is Q naught? Q naught should be equal to C into E. So this will be 4 C naught by 3 into this is 4 C naught. Okay, this will be 8 coulombs. So charge got increased here. This will be the final at T equal to infinity. Okay, meanwhile, it's asking what is the heat generated in the process. So how to do? So any additional charge that has flown through the cell? Delta Q. Again, bucket concept. So earlier, what was the charge? Plus Q naught, delta Q entered, and it has become Q naught. Q naught 6, delta Q, this is 8. 2 coulombs of charge is there. So now how to get that heat generated? What is the formula now?
Same formula.
What was earlier energy of the system? So heat generated, see it's telling the system is again allowed to attain a steady state. What will be the heat generated in this circuit between t equal to 0 to infinity? I have put a slab. I have put a slab. After putting slab is what is asking heat generated. Am I right? So already there was energy in the capacitor. What about the to put a slab extrusion does work? No, what to do with that? Shall we consider or should not be considered?
After putting the slab, na, sir.
Is putting after putting this slab, no? So therefore, what we have to do is like here, what was the earlier energy was there after putting this slab? There's a condition is there. So there was some energy in the capacitor earlier. The battery did work, and some current will flow across the resistor. So this is what the heat generated, no? So here's what that heat will be generated. So shall we go for initial potential in the capacitor is equal to work done by the cell is equal to final potential energy plus heat generated, where heat generated across the resistor. Ui plus Ui, this is Ui, this is UF. Initial Q naught square by 2 C naught, work done by cell, delta Q into E, Q naught square by 2 C plus H. Or even this UI I should bring or not. So the moment you put, the charge will not change suddenly here. Actually, if you put a